Hello friends and welcome to my channel. Today I will introduce how to build a C program using GCC. We will start with a simple program using a single C file, then move on to building a program with multiple source files. And at the same time, we will also learn how GCC works under the hood. This is beginner tutorial, so I will explain concepts in very simple terms so you can easily get the overall ideas. Okay, let's get started with a simple program, Hello World. We create a single source file, main.c. Okay, we got a simple program, only print Hello World. Now, let's build it. We will use GCC to build the program with this command, GCC, and we specify the source file. Okay, now we got the output here. This output is binary file, an executable, ready to run. We can just run it. Okay, you can also tell GCC to name the output file anything you like. For example, we can name the output file my app. Here you add the parameter -o with the name of your output file and execute it. And that's how you build your first C program with GCC. Congratulations! Over time, you will continuously add in code to your program. For starting, we add all the code to the main function like this. This is just dummy code for demonstration, but you got the idea, right? And then, when the main function grows too big, we split into different functions like this. And again, when this single source file grows too long, we want to split the code one more time into multiple files. Done. Now we have a program with two source files. Let's build it. This time we have two files, so we need to specify them both in the build command. Oops, a lot of warnings here. But look like the build is still a success. We still got the output binary here. Let's try to run it. Still working fine, but why? Let's slow down for a moment and take a look into how GCC actually works. So far, we only call single CCC command, but under the hood, it actually does many steps. For a beginner, let's keep it simple, and we can say there are two important steps. That is, compile and link. In the compiling step, GCC will transform the source file into the object file. Object file is in binary code, machine code. Note that the compiling will be performed on each file separately, independently. So we got two output object files, main.o and library.o. Next is the linking step. GCC will take all the object files and transform into the single final output executable file so that we can run it. Okay, that's the idea of compiling and linking. Interestingly, GCC allows us to perform each step separately, one by one. For example, to compile only, we can use the parameter -c. Let's try with the main.c. This time, only compile, no linking. Adding parameter -c. Okay, we still got the warning, but the compiling is a success. We have the output object file, main.o. Let's compile library.c as well. Also success, we got the library.o. Now, note that the warning is only specific to the file we compile, because each file is compiled independently, remember? Okay, compiling step is done. We got 2 object files. Let's move on to the next step, link. We use similar command at the beginning, but this time we specify the object files instead. Good, now linking step is done. We got the final binary and it's working fine as well. You may already notice that we have no warning at the linking step. That confirms all the warnings are at the compiling step itself. Let's see what exactly the warning is. The warning is implicit declaration of function say hello. That's because the compiling step is on single file. The main.c alone has no idea about the say hello function. Let's see what's in the object file main.o. In the symbol words, we have a sequence of instructions. At the line that calls say hello function, it knows it has to execute something, but it hasn't known the detail yet. So it marks that line as the placeholder and move on. On the other hand, the library.o contains the detail that the main.o needs. So later, at linking step, the linker provided with all the object files. It knows what the say hello function is. So the linker fills the placeholder with the implementation of say hello. Now we got the complete file executable. Come back to the warning. C is a strict language. The compiler needs to know at least how the function looks like to be able to call it safely. So to fix the warning, we just declare it explicitly. We declare the say hello function. Just that. Let's compile again. It will be no warnings here. The same warning in the library.c for the printf function. This case is a little bit different. The function is already declared by the system library stdio, so we can just include the header file. I will come back to this later. Now, just compile it. Okay, so we fixed the compiler warnings in all the files. Now, let's perform the linking step again. And run it. Okay, still working fine. We can also build with single command, like what we did in the beginning of this video. Okay, single command directly from C files. Then run it. Okay, let's talk about the header file stdio.h. Here we include the declaration of printf function exiting from an external file stdio.h. But can we declare the function ourselves? Yes, you can. We make it exactly just like the stdio.h, and we don't need this include anymore. And recompile it. Okay, also no warning, everything is the same. Technically, there's no difference to when we use include stdio.h, the header file. So what's the point of using the header files? Well, an obvious benefit is reusability. The library developer can make the header file that contains all the declarations that the library supports, so that anyone can just include it, no need to redeclare again. The header file is also like a public contract. The user doesn't have to scan the whole library code to find the function he needs. Instead, for instance, just look into the stdio.h to see how to use the function printf. Okay, so go back to our code. Actually, we are also a library developer because we make the library.c, right? Maybe we should also create header file for our library. Okay, we have the header file. Now add the declaration to it. Now in the main.c, we can include the new header file. Library.h and remove the manual declaration. And in this file, we don't use any function from stdio, so we can remove it. Done. Let's compile again. Okay, still working fine. In fact, when the compiler sees the include statement, it just simply copy all the content of the header file and replace into that line the include statement. That's why either manually declare the function or include from the header file. At the end, they are all the same. We can include the library.c directly like this. And we can compile again. Here we compile and link all the source files and got the error. How about we do two steps separately? Let's compile first. And then do the linking. Now we link it with both the object files. So clearly it's linking error, and the error is multiple definition of say hello. That's because in main.c you include a C file, so that the compiler will just simply copy that whole C file into the main.c, and that creates two say hello definitions, one in the main.o and one in the library.o. So when we try to link those two object files, there is conflict and the error is shown. Let's fix it. We can see the main.o already has the say hello implementation, so we don't need library.o anymore. We can just link only the main.o. Okay, it's working fine. So, should we just include library.c directly always? No, we shouldn't. Because when include like that, we effectively create a big file main.c, and it will take longer to compile compared to when we have multiple smaller files, because the compiling step is performed in parallel. Another reason, if library.c is included in multiple places, the multiple definitions error will occur anyway. For example, so we create the component.c, so include library.c, and inside the main function we include the component.c. Let's try to compile it. So we get the error redefinition of say hello. So the first definition is from the include library.c statement. And the second definition is from include component.c, which is included in library.c one more time. Let's clear things up. Okay, so this is our final program. We have main.c, which is our main app logic. It uses the say hello function provided by our library. Our library.c is the real implementation of the say hello function, and it exposes the function declaration in the header file as a public contract. Okay, so let's quickly recap what we learned so far. We learned how to start with building single file, and then we can build multiple files. Then we learn how different is compile and link. We know the difference between the source file, object file, and the final executable file. We can also compile only or link only. And then we learned about the header file, why, and also the include statement, what it actually does. So that's it for today. Stay tuned for the next video where I will explain the external library, the static library and dynamic libraries. See ya!